Okay, next up is the rational graph. It's got some differences to it. Let me kind of scroll this up here so we can look at it. All right, so if I pick negative numbers, so if -2, I get negative a half. -1, I get -1. Okay, 0, I get undefined, and we'll kind of review that in a second as to why. 1, I get 1, and 2, I get a half. Okay. Now, with the rational function, with the parent rational function, you actually have a set of asymptotes. And later on, we're going to go through some properties of rational. So for this particular section, I'm just trying to review with you some basic concepts of how rational functions work. So we have an asymptote on the y-axis and the x-axis. And then the actual graph itself for this rational sort of hugs the asymptotes in the first quadrant and hugs them in the third. And notice I didn't really plot a lot of points, but that's okay. As we looking at more parent graphs, we'll see there's some patterns that we can take advantage of. Now, as far as domain goes, on the x-axis, I'm skipping. I have every number except 0. So this is more of a review on how to write that. So I'm going to go all the way up to 0, and then I'm going to union 0 up to infinity. Now I don't want brackets on 0 because I don't want to include it. I want to skip. I want everything before 0 and everything after 0. So I'm going to union in between. And then the range is actually the same notation, same thing, although this time we're skipping the 0 in the y direction. There are no x-intercepts or y-intercepts in this graph. It doesn't actually cross any of the graphs. And again, later on in another section, we'll go through more detail on the rational function as to why that is. Natural log. Again, we're going to go more in depth later on. But there's a couple of points that we can automatically graph on this. Now, I'll still set up a table of values to kind of talk you through this. In this case, if I want... Okay, so this has got some slightly different properties going on here. So I'll kind of do some basics here. Easiest one to remember with ln, anytime you take the ln as 1, you always get 0. The ln of 1 over e is -1, and the ln of e is 1. And again, the later section we'll cover some properties of the natural log and review some more specifics there. But for this particular section, I'm trying to get us just to remember what the graphs look like. So there is an asymptote on the y-axis for the natural log function. And let's see, it crosses at 1, 0, sort of at 1 over e. There's a little point there. And at e is about 2.71. There's a point there. So it kind of hugs that way. And then it continually increases in the x direction. So the y values get bigger. Now, as far as domain goes, domain is bounded by 0, so it's not actually going to ever equal 0, but it's going to increase after that. The range actually doesn't have a bound. It does cross the x-axis at 1, 0, and it does not. In this case, there is no y-intercept. Okay, so we're going to keep going to the next parent graph. This time we're looking at e to the x. E to the x is related to the natural log graph, in that it's got similar properties, although it does look a little differently. All right, so let me start with table of values again. All right, so we're going to use at -1, we get 1 over e. At 0, we get 1. And at +1, we actually get e. And there's another asymptote here, this time on the x-axis. And plotting those points. It goes through 0, 1, and let's see, 1e. E is about 2.71. So it's going to hug that asymptote, and then it's going to curve up. So the green figure is actually the E graph. Now domain, we're still going from negative infinity to infinity. Range, this time we're bounded by 0 going up. It does not cross the x-axis. It does cross the y-axis at 0, 1. Okay, now something interesting happens when we compare it to e to the negative x. Kind of scroll down. I'm going to use the similar numbers, but you're going to see a slight direction change here. So I'm still going to use negative 1, 0, and 1. However, this time when I put negative 1 in, I get e. I still get 0, 1. And this time when I put 1 in, I get 1 over e. There's still an asymptote along the x-axis. And I'm going to plot those points. So we still go through 0, 1. This time it's negative 1e. And there's that other little tiny point. I don't know if you can see that. And so the graph sort of reflects itself, and that's to be expected across the y-axis. So the e to the x and negative e to the x look very similar to each other. Okay, now domain, negative infinity to infinity. The range is everything up on the positive side, so that part looks the same. It still doesn't cross the x-axis, and the y-intercept is the same. Okay, and then if we're going to talk about parent graphs, might as well talk about some sine, cosine functions. Since we're going to talk about parent functions, might as well include sine and cosine. Again, there's later sections that will address more depth on sine and cosine, but since we're here, we might as well look at it. Okay, I'm going to do this kind of backwards on this one. I always like to think of the 5 critical values when it comes to looking at sine and cosine. So they would be start at 0 to 2 pi, and then you do halfway in between. So halfway between 0 and 2 pi is pi, halfway between 0 and pi is pi halves, and halfway between pi and 2 pi is 3 pi over 2. And then amplitude would be 1 and negative 1. So as far as making a table of values go, I would just pick the same critical points that show up in the graph. Now, sine starts in the middle, so it's got at 0, 0 as a value. And then it goes up to the top, so at 0, 1. And then pi is back at 0. 3 pi over 2 is negative 1. And 2 pi is back at 0. So plotting that graph, I go from 0 to the top, to the middle, to the bottom, to the middle. And then hopefully you end up drawing a smooth continuous curve that goes through most of those points. Now, sine is an forever expansive graph, so that we're just looking at one snapshot or one period of it. So as far as domain and range goes, the domain would be negative infinity to infinity, because we're just looking at one piece of this. Let me try writing that a little bit clearer. Okay. Range, however, this time it's bounded. It actually bounces between negative 1 and 1. X-intercept, that one's not pretty easy. That one actually crosses at the origin. Actually, no, I take that back. The y-intercept goes through the origin. But the x-intercept, it crosses at the origin. It crosses at pi. So there's several examples. So at every And right now I'm not interested in getting to recognize the general case, but it crosses at every multiple of pi would be an x-intercept. But that's good enough for this sort of review. And then last but not least is our cosine graph. And again, I'll start with table of values, but I'm going to again do this backwards. So here's 0 and here's 2 pi. And then if I go to the middle again, I get pi. The middle, I get pi halves. The middle of that, I get 3 pi over 2. Amplitude of 1 and negative 1. Alright, so those critical points would be the ones that I stick in the table. Okay. And cosine actually starts at the top at 1, and then it goes to 0, and then it goes to negative 1, back to 0, and back up to 1. So what would that look like? There's top, middle, bottom, middle, top. And if I connect all those points, again, that's just one snapshot of cosine. So that's just one period of what cosine would look like. And then domain, this time we're still looking at, since it's an infinitely expanding curve, we're just looking at one picture of it. It's actually going to be all real numbers, so from negative infinity to infinity. The range is still bounded between negative 1 and 1. Intercepts, it's got an infinite number of these things, so I'll kind of start a pattern here. So it crosses at pi halves, and then it crosses at 3 pi halves, and then, so every multiple of pi halves, every 3 pi halves, pi halves, 3 pi halves, 5 pi halves, it's going to cross the x-axis. And then as far as the y-intercepts go, there's only one in this picture. There's only one actually, 0, 1, unless we start doing transformations. And so the idea is you should, from memory, be able to recreate all of these parent graphs, know what they look like, and at least be able to identify domain range, x-intercept and y-intercept. So hopefully with this quick review, you feel very confident and very comfortable looking at just basic parent graphs.